Okay, so in this video I want to talk about the attach to component function. And so before I get started, again, you can create a new actor class if you want, but in this case I'll just clean this one up. I don't need these variables. I'll keep these components, so the root component, and then I'll rename this to cone. So I want some cone mesh component, and I'll actually just go and select this stuff and paste. Okay, so I'll create one here called pyramid mesh component, and maybe another one, and I'll just call this one target mesh component. And what I want to do is I want to demonstrate using some of these various components how the attachment works, again using that attach to component function. Okay, so that's why I'm creating these. Here for the target you can actually use a scene component as well, but in this case I'll just leave it like this. Okay, in my .cpp file, very interesting actor.cpp, in the tick function, I'll go and delete that stuff, and I'll delete the initializations of B should move and B should rotate. I need to go and fix this, so rename that to cone mesh component, each one of these instances, so where we do the setup attachment and where we create the default subobject, and here the name as well. I'll create one for pyramid mesh component and one for target. So just to save some time, I'm copying and pasting, but of course what you can do is you can go and type these out. So all I want to do is I want to create default subobjects here, use static mesh component for each one of these, pyramid mesh component and target mesh component. And again, I'm passing it the name of the components right here. So for now, I'll just leave it like this. Okay, next I want to set up attachments between these new mesh components and the root component. So just like we've done here, again in the constructor, in the .cpp file. So I'll do that right here. Pyramid mesh component. Set up attachment. Okay, like that. Similarly, okay, so we have all of these set up now. So all of these mesh components will now be attached initially to the root component. So let's say we want to change this during begin play. We want to attach something like one of these mesh components to another one. So that's what we'll do. I'll use the pyramid mesh component, and I'll do the attach to component function. And as soon as I type out those parentheses, you will see it takes in a using component. Now, since these mesh components are using components, since they inherit from that, that means we can pass them in that first parameter. Then we have another parameter here, if attachment transform rules, and you have, that long thing, and you have a bunch of those rules. Now, this is one way of getting to that second name, and it's if, so that should indicate to you that this is a struct. But basically what I'm getting at is this IntelliSense, so this pop-up that you get here as soon as you type out the parentheses, helps you to remember what that name is that you have to type out for that second parameter, because it's a bit long and as a beginner you might forget that thing. So you don't have to always go and open up the documentation. That thing is right here. If attachment transform rules. So we'll get to that in just a second. Right now I want to pass in that using component, and that is of course the target mesh component. And then for that second parameter, we have the if attachment transform rules. So here in the documentation you can see if attachment transform rules, rules for attaching components. And if you scroll down, you can see we have keep relative transform, keep world transform, snap to target including scale, snap to target not including scale. So the goal is to do a quick demo of each one of these, just to give you a basic idea of what they do, and eventually we'll be using them in some of our projects. And if I do 2 colons, we get this drop down, okay, with all of the options. So again, that scope resolution operator gives us access to these members. So what you'll be using here is you'll be using keep relative transform, keep world transform, and then you have snap to target including scale, snap to target not including scale. So for right now, we'll be using this snap to target not including scale. So again, an easy way of finding these members. Firstly, finding this very long thing, you can use that IntelliSense pop-up that I talked about, and then finding the members. As soon as you tap out that scope resolution operator, you will get this. Okay, so it makes it easier to remember all of this stuff, because you can see these long names. Snap to target, not including scale. It's kind of a long name. Okay, I'll just press tab and we get this, and I'll end that off with a semicolon. One more thing I want to do before I build this is I want to move that target mesh component. So I want to offset that a bit, as compared to the rest of the components. And we can do that using a function, add world offset. And as soon as I bring up the parentheses, you can see again you have the constructors. So you have default constructors, you have an F vector. So I'll just do an F vector. So I want to move it along Y. So minus 150 in Y, and then I'll do 0 as well for Z. So in a second, when I bring up Unreal Engine, you'll see what will happen. But basically, we are adding world offset to this particular mesh component. You remember previously you have something called, you can see add actor local offset, add actor local rotation, all of that stuff. So instead of applying a offset to the actor, so this particular actor, I am applying that offset to the particular mesh component, in this case the target mesh component. That is pretty much all I want to write for right now, so I'll just build that and hope we don't get any problems. Okay, and we have a succeed. Actually, on second thought, here where we have in the constructor, where we have this target mesh component, add world offset. Okay, I added a negative offset right here for Y. So I'll just change that to positive. So 0, 150, and 0. And I'm adding F here to indicate that these are floats. Okay, so again, just a simple change from minus 150 to 150. Doesn't really matter all that much, but I've decided to make that change here. And I think that is that. I'll build and run this. Okay, I'll open the my very interesting actor underscore BP, that blueprint class again. And go to the viewport, and I'll go and add static meshes to these components. So the cone mesh component, of course, under static mesh, drop down, I'll go and search for a cone. Okay, select that. And then the pyramid, click this drop down again to pyramid. And in this case, I'll select the quad pyramid. Okay. Now for the target mesh component, I'll just select maybe a sphere. And you can now start to see that offset happen already. You can see with that component selected, the target mesh component, you can see in the transform location, you can see it's minus 150. If I change that, you see this reset to default comes up. If I left click on that, it goes back to 150, and that's because that is set in the constructor here using this add world offset. Okay, so what I'll also do is I'll change the scale. Maybe I'll do 0.5, make this relatively small. Okay, and what I'll also do is I'll left click and drag on each one of these components, and I'll drop that onto the pyramid mesh component. That's the one that we will be moving around. You can also select all of them and drag and drop. So those are now children of the pyramid mesh component. So the cone, we are not going to move that around. It's going to stay in its place for the most part. At one point we'll rotate it a bit, but for now we'll leave it as is. And the pyramid mesh component is what we'll be moving around. We might at one point come and remove this shape, but for now I'll leave it. And the pyramid, you can apply some material if you want. You can also click the view options, and then you can click show engine content, for example. So if you do not have the starter content, you can still get, so under static meshes, for example, you can still get various shapes and stuff. You have that available, and similarly you can have various materials that show up, such as the default material, for example. So you can apply some material to that pyramid if you want. At some point it's going to rotate around, which might make it easier to see, but since it is a pyramid shape like this, it should be easy enough to see. Okay, so for right now I'll just compile and save this, and you can see by default what the setup of this looks like. All these mesh components are children of the root component, and under pyramid mesh component we have these arrow components as well. Okay, so with that saved and everything, I'll go into my world and I'll just drag out a new copy of this, and I'll actually just delete all of this stuff because it's kind of in the way. Just delete all of this stuff, it's kind of in the way, and I'll drag in a new copy, and I want that to be zeroed out. So I'll move some of these things around, just kind of get them out of the way basically. And I'll just save all. You can always start with a cleaner map, but I'm just quickly trying to show you here. Okay, so this is more or less the result that we get. Okay, I'll just stop here for a second and select that, and you can see by default what we get. So you have the root component. Now this top one you have to remember is the actor itself. You can see between parentheses self, and then you have under root component you have these mesh components, and then you have pyramid mesh component, which has as children those arrow components. Right, so as soon as I click play, you remember we have this function in the begin play that says attach to component target mesh component. So that target mesh component is that sphere right now. So in this case, instead of clicking play in the selected viewport, I'll do simulate. So I'll just simulate that instead, because in this case it is ejected by default. So in this case you have to possess now, okay, if you want to. So just another tip for you. Okay, so I'll select that actor, and then you can see this has changed, the hierarchy has changed. That pyramid mesh component is now a child of target mesh component. Okay, again because of this attached to component function in begin play. And as you can see, it keeps those arrow components as well. Another thing I'd like to notice is with that selected, the target mesh component, the scale is set to 0.5, but the pyramid mesh component, its scale here actually changes because again it has to try and keep its original scale. Okay, so it has to multiply that scale by 2 to try and keep its original scale. If I select the target mesh component, that's 0.5, and the pyramid mesh component now is 2 to again maintain its original scale. And that is because of this parameter here, if attachment rules snap to target not including scale. So what I'll do is I'll stop this and I'll go back to Visual Studio and I'll do including scale, snap to target including scale, right? And I'll just Control B to build that, and that should compile fine. Okay, that build is complete, and I'll just go and play this again, and now immediately you can see the difference. It does not maintain its original scale. Okay, I'll stop. You can see its original size. soon as I play, you can see that changes. Okay, and that's because it's going to inherit now that scale. You can see if I have the target mesh component selected, again the scale is 0.5 uniformly. So in other words, X, Y, and Z is 0.5. And if I select the permanent mesh component, you can see that is actually set to 1. So this is not going to be 0.5, okay? This is going to be 1 because it inherits from the parent. Again, if you change this now, so if I change this to 2, it's going to basically revert to its original scale before, we click play. If it was 0.5, again, you have to remember with scale, it's a multiplier, so it's going to shrink down and it's going to be a quarter, 0.25, as compared to its original scale. So I'll just stop here. You can see basically what happens. It is going to basically multiply with the parent scale, if you want to think of it in that way. Okay, in this case, I'll actually just close off Unreal Editor here again, because I'm going to make a few changes in the constructor. Okay, so back in the constructor, what I'll do is I'll change this setup attachment where we have the permanent mesh component. Okay, it's currently attached to the root component. So what I'll do instead is, just to make it clearer, I'll kind of bring it down here. I'll do the setup attachment to the target mesh component instead. So that should mean that as soon as we have that actor spawned, so by default, since this is in the constructor, this will be attached to the target mesh component, or in other words, the permanent mesh component will be a child of the target mesh component. Okay, then I'll scroll down here to the begin play. What we'll do is we'll attach this to the cone mesh component. So again, previously when we hit play, the permanent mesh component would have been attached to the target mesh component. But in this case, the permanent mesh component will start off being attached to the target mesh, or a child of the target mesh component. And then as soon as begin play is called, or as soon as we hit play, that permanent mesh component will be attached to the cone mesh component. Okay, so I'll scroll here and I'll change this rule. We've already seen those scale ones. So what I'll do instead is you have relative and world transform. So what I'll do is I'll select world transform here for this first section, bold, and run this. Okay, so remember that we made some changes in the blueprint class. Okay, so with regards to the target mesh component, I'll just reset the scale here. Okay, so back to 1 uniformly, and I'll compile and save. And in some cases you have to go and delete the actor. You can see that it has not updated here on this instance, so I'll just delete that and drag out a new copy. Okay, and here we can see our actor. If I have that selected, and in the class defaults, you can see that under root component we again have the cone mesh component, and then we also have the target mesh component. Now under target mesh component, you can see it has a child, and that is the permanent mesh component, and the permanent mesh component has those arrows attached to it. Okay, so this is what we get with that. I'll just save all. Okay, so if I now hit play, remember that at begin play, permanent mesh component will be attached to the cone mesh component. Okay, so if I hit play, you can see pretty much nothing happens, but if I have that actor selected now, you can see what happens. So again, we have the root component, the cone mesh component, and the target mesh component. And so under cone mesh component, you can see as a child, it has the permanent mesh component, and that is at the location 0, 150, and 0. You have that set to relative. So what I want to do is actually, I'll stop, select that actor again, and I'll reset this. And if I play again and select this actor, the cone mesh component should be at 0, 0, 0, as you can see. And the permanent mesh component should also be, with its relative or world, it should be at 0, 150, and 0. You can see right here. So I'll just stop that and go back into Visual Studio. Okay, so in begin play, right before we do the attach to component, I'll do permanent mesh component, and I'll do add world offset if vector. And so what I'll do is I'll add an additional offset to the permanent mesh component in Z. Right here, we move the target mesh component in Y, okay, 150 units. And then what we are going to do is the permanent mesh component itself, we are going to move and give that a world offset of, let's say, 50 units. In Z. And then we do this attach to component. Build this and we'll see what happens. Okay, so I'll just hit play and I'll select that data actor. And now if I go into the tree, again the root component here is at 0, 0, 0. The cone mesh component is also at 0, 0, 0. But the child of that is now at 150 and 50. So this target mesh component is at 150, okay, by default, which is set in the constructor. And the permanent mesh component will basically keep this offset. You can see it's relative and world. Both of those have that offset. And that's because we used this world rule, so keep world transform. Okay, with the if attachment transform rules, we set that to keep world transform. Okay, so I'll just stop this. And actually, if I select and move that target mesh component around and I hit play, you can see what happens. Okay, it's going to keep essentially the world position, so where that permanent mesh component was. And I can actually even rotate this thing. So this cone, for example, this cone mesh component, I can select that and I can maybe rotate that a bit. Okay, maybe something like that. And again, I can go and hit play and you can see it'll kind of keep that location. So the main thing is it's going to keep its world position basically. So it might have to go into update. So if I select this actor now that I've stopped and I select the permanent mesh component, if I select world, you can see it's -510 and 840. And as soon as I hit play, select the stuff again, select the permanent mesh component, you can do world and you can see world updates as well as relative. It's also a different value now. So basically what happens is it does a bit of calculation for you to keep the world position so that you don't have to do that by yourself. Let's just drag out a new one here actually. Okay, so what happens is before we hit play, the permanent mesh component is a child of this target mesh component, which has this offset 150. So of course this permanent mesh component will inherit that. Again, if you go to the world location of that, you'll see y is 150, even though relative is all set to 0. Now, as soon as we hit play, what's going to happen because of this, again, this attachment rule, keep world transform, it is going to keep its world transform basically. Because remember, as soon as we hit play, if I just go here, as soon as we hit play, so we'll do some offset here, and then it's going to attach to a different component. It's going to attach to the cone mesh component. Okay, so it's going to attach to this component. But because of that rule, it's going to keep its world location. So let's hit play here and you can see that's what happens. So permanent mesh component, you can see the relative position now is 150 and 50. World is also 150 and 50. So it's going to try and keep that world transform. So as you can imagine, if you want relative transform, that's something different. So I'm going to select the cone mesh component and rotate that around a bit. Maybe something like that. And similarly, if I hit play now, you can see the same thing. If I select the permanent mesh component, and it's going to try and round y off here and 50. So cone mesh component, you can see the location is zeroed out, because again we're working with floats here, so it's not an exact number. Okay, so you'll see like a bunch of numbers, like so after the decimal you'll see like 999 and so forth. Okay, but that's fine, that's more or less the same position. Okay, I'll just hit stop here. So let's just change this, and so we'll go back into Visual Studio again, and we'll do keep relative transform. Okay, and I'll build that. So that's finished. And now when I click play again, you can see something else happen. Select that actor, you can see the permanent mesh component is still a child of the cone mesh component, but you can see the transform has changed. It's now going to snap basically from that sphere, which is the target mesh component. It's going to start over there, but then it's going to snap to the parent, okay, to the new parent, but instead of keeping its original like world transform, it's going to now apply whatever relative offset that you might have. So again, if I click play and select that and select the permanent mesh component, if this is set to world, you can see a bunch of values, but relative, it is offset in Z to 50. Okay, and if you move this, you can see, okay, it's gonna move like that, and I'll just get a better angle, and you can see what this does. Okay, it's gonna move it like that more or less, because this component here again is rotated. I'll just stop here. This guy right here, the cone mesh component by default, has been rotated a bit. You can see in the rotation right here. So I'll just set that to 30, minus 30 in X, 30 in Y, and minus 8 in Z, for example, something like that. Okay. So back in Visual Studio, of course, if we take this offset away here, then it won't apply any offset, because it won't take this as an offset, okay, this that we apply to the target mesh component. So again, this actor starts and basically inherits the position of the target mesh component. Okay, as you can see, if I set that again to world, you can see that inherits that. Okay, and again, it's going to try and keep that original position if you have it set to keep world position right here, keep world transform, that is. Now, when we go and apply the attach to component, it's not going to be concerned with that offset anymore, with the world offset. It's going to look at what local offset do you have. Again, when it is set to relative transform, it's going to basically look at the relative transform. And what we have here is this add world offset. You can actually do relative offset as well, but I'll just leave it like this for now. So it's going to only take this offset, because you remember previously when we had keep world transform, it applied this right here, and then it applied this offset as well, and it would also keep that when we had again this set here to keep world transform. But when we have it here to keep relative transform, it's only going to look at the transform that is applied to that particular component, and in this case the only real transform or relative transform that we have applied to this pyramid mesh component before we do this attachment is this right here. So it's not going to care about what you did, to other mesh components. It's only going to, so here again we do target mesh component, add world offset. Here we do it an offset to the permanent mesh component. And I'll just do a bit more here, so 100 maybe. Of course, if I actually comment that out for a second and build this, again it's still set to keep relative transform. You can imagine if we go in here, and as soon as this finishes and I click play, it won't move anywhere, because it's just going to keep that relative location And we did not apply in this case because, again, this is commented out now right here. So we did not have any offset applied to this permanent mesh component. Okay, and if I hit play now, you can see that it is basically zeroed out. So I'll select the cone mesh component. You can see it's 0, 0, 0, and the same for the permanent mesh component as well. So again, you can apply some offset using add world or add relative offset. And then what you can do is, since that component now has that offset, you can use this if attachment transform rules, keep relative transform to keep that transform relative to whatever it is that you are attaching to. In this case, the cone mesh component. Okay, so just for fun, in the tick function, I'll do add relative rotation, and this takes in an F rotator. And so I'll set the yaw to 1, so it's going to rotate by 1 degrees per frame basically, okay, every tick, just to give our actor some rotation just for fun. Okay, so I'll pull that. If I hit play now, you can see what happens. You can see that actor will rotate. And again, the permanent mesh component, the relative location, you can see Z is right here, and you can move it like that now. Okay, relative. You can see that is applied relative to this thing because this cone again has been rotated. Okay, we applied a rotation to that previously. I'll just stop that, and I'll actually just save all and close out the editor for right now. Okay, another thing I'd like to mention before we wrap up is that sometimes we have deprecated functions or members, and it's important to check this error list. You can see that here we have no issues, and if you check the error list, you can see we have no warnings and such, but it's a good idea to go and check. In that way you can see, like, if you are using something that is deprecated again meaning that its use is discouraged. Let's just look at an example. Permanent mesh component. And let's say we want to set the relative location. So we might search for, you can see relative location, relative rotation, and then you can do a dot x, and then you can set that to, let's say, something like this. Okay, so in this way we can add relative location to this component. Okay, you can see plus equals 100 units, and I can actually bold this now. So I'm not going to run it, I'm just going to bold. Okay, and down here you can see no issues found. So what you can do is you can check the error list, and then you can see here using component relative location. This member will be made private. And it actually shows you here, please use get relative location or set relative location. And please update your code and so on. Otherwise your project will no longer compile. So in other words, when the next release comes along of Unreal Engine and you upgrade or try and upgrade your project to that new engine version, then your project will probably not compile. What you can also do is you can right click. So we have this relative location. You can see it's not a function. I'm simply accessing that member. So X I'm accessing here directly, and I'm adding 100 to it. So what you can do is you can right click on it, go to declaration for example, and now you can see they use a macro UE_deprecated, and then you can see this comment. The string here says this member will be made private. So that is what shows up in that error list. And again, what's useful is it also gives you hints basically, okay, what you should use. So please use get relative location or set relative location instead. Okay, I'll just close that off, and that is in the scene component.h, so the header file of the scene component. Okay, so I used add world offset, as you can see, to these components, but as you can see, you can also do set relative location, for example, or add relative offset. You can also do so. instead of doing this, I'll just do, and you can see you can do add relative location as well. Alright, so I spent quite a lot of time in this video discussing pretty much the attach to component and the various attachment transform rules. And it was just a basic example. We'll probably see some of these again as we go along throughout the course. So this was probably not the most exciting video, but I wanted to highlight a few important things. So it's not just about the attach to component function or the attachment rules. It was also about the fact that we can rotate or translate, basically change the location of individual UScene components or uStatic mesh components. Also, as we've seen in the begin play function, we set a component to be a child of a different parent, basically. So we can change like the tree structure and the parent-child relationships as we need to. So just a few basic examples. I did not cover all of the functionality relating to this function, because for example you have sockets as well. Now we haven't talked about sockets yet, so I'll just leave that final parameter to the default. Okay, so I hope you found this useful, and I'll see you in the next video.